Welcome to today. Today we're going to be going through the site drainage and going through our contours and site plans. So what's happening here? Well, you guys have all done construction practice and you've gone through, you've set up your laser, you've walked around with a big stick and taken your spot levels around the Tonsley campus. So what we do is we acquire a block, or our clients acquire a block. We send out our subcontractors to do the leveling. They'll set up their laser around the block, walk around with the big stick and get the appropriate levels. Now how does that look when it comes to us? So they'll get the levels, they'll convert it to a CAD file, a DWG, then they'll send us that. There's two different types of contours that they'll send. We either get 2D or we get 3D. So we will look at 3D when we do Revit, but for now we're just going to look at the 2D drawings. So this is what they look like when they come to us. This is two different survey plans. This one's very busy, so we'll start here. This here is what the file looks like when we receive it. So what's happened is there's obviously an existing house here. This is the street, house, the backyard and everything else. These plans are just showing the levels and the things in relation to the block, to the site. So let's go through the, I guess what we can see here. We have two different lines. We have yellow ones and red ones. These are the contours, okay, showing the levels or the elevation of the land. So the yellow is the major contours, the red is the minor contours. All these numbers sitting around here are our spot levels. This one here, okay, is showing the level for the major contour line. From the street, obviously, street name, WT, TK. So WT is the level of the water table, TK is the top of the curb. TBM is our temporary benchmark, which is a bolt on the stobie pole, and it has an RL of 100. So RL, reduced level, TBM, temporary benchmark. So what they'll do is they'll bolt down to the bottom of the stobie somewhere or use an existing bolt. They'll spray it with yellow and that's where they'll take their 100 from. So basically what happens, this is their 0 mark and then we're going up or down from there. So what we can see is obviously all of these numbers are slightly less than 100. So the stobie pole is higher than the rest of the block. And now we start looking at the fall. So if I start here, I have 99.94, then I have 99.58, 99.09, which means the block's falling backwards. These numbers are getting smaller the further back I go. Next thing we can see here is all this little green stuff. These are our trees. The notations in here, S, H, and C. S is the spread of the leaves or the branches of the tree. H is the height of the tree. C is the circumference of the tree trunk. So we have some pretty big trees sitting here. So as you'll learn in geotech, this isn't the optimal thing to have next to your house. These here are our neighbours. So it looks like we have a neighbour at the back, we have a neighbour on the right with a fair distance here, and we have a neighbour on our left-hand boundary. There's no contour lines through here or levels. Our contractors aren't obviously allowed to walk through our neighbour's property, but they'll just show roughly where it is. We don't need these here for site drainage, but we do need them in our site plans, which we'll get to down the track. Levels here on the driveway and a few levels on the carport. No levels inside of the house. We have an approximate finished floor level and things like that, but obviously they can't walk through the house. We assume the house is locked and there's no point, the laser's not going to go through the brick. Shed in the backyard. What else have we got? Well, TRW, top of retaining wall. So we have a retaining wall sitting on this boundary here. Alright, and we have the level to that as well. So it's pretty flat, not a huge difference in movement. It goes down a millimeter, then up. It's a pretty flat retaining wall. So there's not a whole lot of movement there. Regarding the height of that wall, usually retaining walls, we try not to step them. Whereas we can see in the block, the spot levels here starts dropping pretty dramatically toward the back. What other annotations have we got? Well, we've got WM here, which is the water meter. The other thing you will also see is at the front you might have KNG, which is the curb and gutter, and you also may have SWO, which is a stormwater outlet, which I'll go through on Thursday when I see you. So let me just copy this one so we can have a look and see what's happening to the land. I know the numbers can be a bit difficult to try to interpret, sorry, I don't know what the hell interpretate is. RL is 100, so here is lower, but this is still higher, so 94.4, 95, 58, 09, then back up to 10, and then back down. So the block is falling backwards, and now we'll look from left to right. 58, 2, back up, back down. Let's have a look what's happening back here. These here, alright, so it's falling from right to left. This is higher than over here at this point, and then through here again, so it's looking like it's also falling back to this corner, but the back doesn't. Okay, this is lower than here. So we get different changes in our land, which you can expect. If you walk through a block, they're not dead flat, there is changes in it. The other thing that you need to also be careful of is we could have localized high points. So what I mean by that is, if I come across here, look here, 99.58, 52, 52, 6, and then back down. So this here is a high point. We need to be careful, and often it's a good idea to go and check the block, because if we have just a mound of dirt or something here, or a sand pit or something in the front yard, they can all affect our levels. So we have to obviously advise our contractors, they should know, but we have to advise them, if there's a big mound of dirt here for whatever reason, say they're doing renovations or something and they've got a pile of earth sitting here, we don't take levels on it, we go around it. So you just have to also be careful as to what's going on. So back here, so we can see the levels, well, I'll take the, let's take the Stobie pole to start off with. I'm just going to take a cross section of the land so we can see what's happening. So let's take a few points here. Let's take this one. Let's take this one. The more points we take, the more of an idea we can get without such sharp slopes in it. But just understand the fall of the block, this will be sufficient. And let's grab the back, which is, say, roughly here. Quite often we can assume, so this level here, we can assume it's around here as well. So they're not exactly just this one point is that height, there's a perimeter around it. So this I would take as my 100. So this point here, this intersection between these two lines, is my RL of 100. And then what happens? Well, I have a small fall towards the street, which isn't the end of the world. So let's take it from, say, this line, so we can show that slope. So what happens? RL of 100, I have 99.97. These are all in meters. Okay, so 7 to get to 100 is 30 or 3. So 3 is 30 millimeters or 3 centimeters. So let's copy this down by 30. Draw a line from the intersection. So this point's my 100 to here. Now I can delete this line, trim, enter, trim this one, trim that one. So this is my slope to the street. So it's pretty flat around that footpath there, which we can expect. You're not walking on a mountain when you walk down a footpath. And then what happens? Well, from my 100, it comes down to 5.8. So up to get to 60 is 20 millimeters, to get to 100 is 420 millimeters. So we're coming down 420. Copy from here to here, draw a line. So that is my first slope. Trim to here. So it starts sloping down. Alright, so gotta imagine the car comes up and goes down the driveway to the carport. Now what happens over here? Well, 98.44. So we're further down again from here. So we're still moving downwards. So to get to 100, which is this point, again, just taking my datum line. What's that? To get this up there, 6 brings me to 5. So 560 will get me to 1.56 meters. So a huge drop again. So copy down. 1560. Line from here to here. So we can see our block starting to get very steep. So I can trim this. I can trim that. Okay, so we're starting to go further down. Now what happens here? Well, we keep going. So further down, to get this to 100, always bring it back up to this reference level. What's that? 1.98. So copy down. 1980. So the change between these two isn't a huge gradient, but compared to where we started, it is. Let's trim this. I can then delete this line here. So still coming down. And then what happens here? Well, I have another significant drop. So this is my 100 line now. Copy this one down to bring, look at this number here, 74 or 97.74 to get to 100. What's that? 26 gets me to 98. So 2260. I think that's right. Yep. So here to here. You can delete these two lines, draw a line back to the street. So this is the cross section of my block. Okay, so starts higher, comes low, comes lower, comes down, and this is the back. So we've got a pretty, steep, pretty steep fall. We can work it out from here to here. 2 meters is a big fall. Okay, so that explains this and what's going on. Now this is the file that we're going to be using. So I will give you the survey mark, the floor plan, and the boundaries. The boundaries are found from the land title, but we can look at that a bit later. Okay, this is given from the bank, or you can look it up. I think it's $36 to get it for your block of land. Let's have a look here. Well, I'm just going to move all of this away so I can start working on it. This is what we get. This is for another house. Okay, see less contour lines here, a lot of spot levels. So these come in all kinds of different shapes and sizes. That's okay. This squiggly line here is the fence. And then the rest of it are the boundaries. So what do we do when we first get one of them? Well, once we first get one, we have to come through and tidy it up. This is that K&G I was talking about, the stand-up curb and gutter. So just be aware of that. So let's come through and tidy it up. So the only thing I want on here, really, the only thing I'm concerned about is the levels. I need to determine the levels of my house. So what I'm going to do is effectively move things. So select everything that I don't want and move it away. Now, I hope most of you have realized by doing this, I'm going to be here for like 9 hours clicking buttons. So, easiest way to do it, we have a lock function. Let's lock what we want. So I want the levels, I want contours, or the major contours, I want the minor contours, I want the major contour levels, I want this fence line. And what else do I want? Let's keep the water meter in there. The gas meter for now, so a bit of this text. Gonna need that, that's locked already. And let's keep this bolt on the stovey. Let's keep that there. So select everything now. Move. Well, let's move it by a known value. So let's move this one by 50,000. Just let it sit over there for now. Let's have a quick check, see if there's anything that I've taken that I want to keep. Well, I want to keep these, because these here are the street. So let's keep them. So move that back over. Is there anything else? No, trees and buildings and everything else. Cool. Let's come through and unlock the text. So now we can select the ones that I don't really need. So I don't really need any of that. Don't need them. This. Don't really care about that. Gas meter I'll keep. Let's get rid of this. Stovey keep. Warning sign keep it. It's in the street. And shed. That can all go. Don't want any of you. Go over there. 5,000, 50,000. Cool. So what I can always do is I can always bring everything back if I've missed anything. So we're just checking between them. But this is, this is okay. So we can go through and line up levels as well, which we try our best not to. Usually we try to leave it to our contractors. I'm just unlocking the layers now. We try to leave it to the survey guys. I mean, obviously on this plan we have a lot of contour lines, whereas here not so much. But how can we map them together? Well, we can map, here's 100.07, there's the same level, so we can assume this line seems to follow. So we can line up points through here, which you'll find or you'll learn more about in your environmental class. You'll be doing mapping contours for your drainage of mine sites. Cool. So I have these now. You're also going to learn more about this in your water infrastructure class and your geotechnical class. So we're going to do the pipe layouts on here, the stormwater, which you'll learn the design calculations for in water infrastructure. We're going to come up with our design levels, which you'll learn about in your geotechnical subject. This is our boundaries. So I'm going to copy from this point will sit here, and it's very far out. So what have I done? Well, that's not a good reference point, as I've just found out. So I delete that. This here is a boundary line. So let's move these back across because I need them. So move them back by 50,000. That looks a bit better. So copy this from this point to here. Now these won't always line up and that's okay. The fence lines here are not always accurate. We have to take the land title, but we have to have like a goodness of fit. So we have to go within reason. Is that cutting through the lines? It is. Here, is it okay? Is it within our boundaries on the sides? It is. The fences here, you have to also be aware that these could be tilting, they could be falling, they could be anything. Our land title is what comes from the urban regional planners. It's always true. So we have to take this as gospel, and we've got a bit more wiggle room with the surveys. Another thing is when you get ones like this that aren't straight, your boundaries will come on a straight PDF. You might have to rotate it. So the boundaries here, if I come straight through, see how it's not lining up? So sometimes we have to rotate it to get them to fall together. So back here, got my boundary, got my surveys. Now what? Well, I have to put a house on here, but what's happening? Let's come back to the actual problem. What happens 9 times out of 10 is a client will buy a block of land with an existing house on it. It's just like this one. They've bought a block, it has a house here. What do they want to do with it? Well, everybody wants to make money, so they demolish the house, they subdivide it into 2, and they build one house here and one house here. Sometimes they can build 3. It's very dependent on the council and how big the block is and everything else. So what we're going to assume is this is getting split from its midpoint. So we're going to have one house here and one house here. So this is our house. I'll just take our house just to show you. Copy. I'll just do this for now. So effectively we'll have one house sitting here and we'll have one house sitting somewhere here. Alright, as opposed to having the one, they have 2. Okay, how do we put this on here? Well, let's find the midpoint of this line, which could be a bit tricky. So, as opposed to me, coming through here and spending everybody's time listening to my beautiful voice going through it, well, let's just take this midpoint. This shape is the same as this shape, so copy from a known point, the corner. Let's copy it down to this corner. So there's midpoint. So that's my dividing line. I have 2 houses coming here now. So what do I need to do? Well, somehow I need to transfer my other block, so my floor plan, onto this plan. So I need to move this to here. Now what you're going to ask is, well, where in the hell does it sit on that block? So we can go through council, we can go through their development plan and go, okay, where's the setbacks, where's this, where's that? But to make our life easier, I'm just going to give you the values. The next thing is I don't need to take the entire plan. The only thing I care about on here, one is the roof line, second is the wall outline. So with a polyline, in green, that will work. I'm just going to take the outside here. With straight lines on, Nathan. To there. To here, to here, to here, to here. Should I just go C and that will close. Okay, so now I've got the polyline for the outside of my house. So let's move it. Well, what I'm going to assume is the front of the garage from this point here. So the garage, this is my boundary. The garage is going to be built hard on the boundary. So now I've lined these up, I can delete this one. From that boundary, actually these little nips here are going to annoy me. They don't need to be there. I don't know why I've done that. So let's straighten them out. The reason why that's not important really is because our roof sits on the outside of it. That's what we really care about. So just for my eyes and the symmetrical of it, for my OCD, well, that's good. So where are we going to put them? Well, let's move this back by let's come back by 6120. Why? Because it's a good number. The reason for that is because we might have a 5.5 meter requirement from the boundary, from the boundary to the garage, as per the council requirement, and then we also might need to worry about the gradient or the fall of the driveway. So this here should be okay. let's check here. On the side, we have to have at least a 900mm boundary, which we do, which is nice. So we have to have an access path to the back of the house, and we have to have a concrete perimeter around it as per the National Construction Code. You will learn more about this in geotech and your design projects, but I'll just download a bit of information to you now. The next thing that I need on here is I need my roof outline. Obviously, any of the water that hits the house isn't hitting the slab. It's all dependent on the roof. So let's grab the roof. So grabbing the roof, all I really need is just the outline for the outside of the house, but let's grab it all now anyway, whilst we're here. Here, here, here. Okay, now I have to bring that across. How am I going to do that? Well, copy from a known point, so I know this corner here is this corner here. So now I have my roof sitting on top of my house. So if I select that all again, what I might do is group it, just move them all together. Cool. And let's group it together. Let's make it yellow. Oh, it didn't work. Select it and let's try again. Let's go for yellow. Just so it stands out a bit better. Well, not really, but you know. Alright, so what's happening? We have to put in our pipe work. So what we're going to do is basically we're going to do a pipe outline. And what you'll find is you'll do this outline and our trades will never listen to you anyway. We have to work out, we have a gutter, so looking at the roof, the water has two places it can land. It can either land on the roof of the house or it can land onto the ground. So what we're going to look at is the roof goes to a tank, from the tank goes to the street. From the ground, which is our runoff, goes straight to the street. They do not cross. So any water from the ground does not go to the tank, goes straight to the street. All of the water, the discharge, runs out here and then down the road. So what that means is the water is going to hit this face of the roof in here. It's going to fall to the right. This little triangle here will fall to the back. This in here will fall to the left. So we need to put in our downpipes. Okay. So how are we going to do that? Well, what I will do is hopefully I've put one on this drawing. I haven't. I will give you the downpipe sizing and the water tanks. Let me just steal it from another drawing for now. If I have one here. No, this one. So let's steal this tank, let's steal this and that, and maybe a pipe as well. Control C, Control V. Scale up by 2. Alright, so now that these are a bit nicer, let's make this blue as well. I will give you these into your drawing, so don't stress about that. But what we need to do is we need to find somewhere firstly for the water tank to sit. So usually, you know, we try to hide it. We'll put it next to a shed or in a crevice in the building or something, so they don't just stand out. But for us here, it's easy to put it at the back. You've got to understand the tank here is lower than the house, as you know we can see. So the roof of your house sits well above the ground. So all the water collected here will run down the pipes to the tank, from the tank to the street. Let's have a look at the levels of our block. What's happening here? So if my 100 is somewhere here, well, 98.84, 85, so it's falling to the right at the front. Here as well, looks like it's pretty flat, maybe falling slightly to the right. Here, pretty flat. Across here, you know, falling back down. This is a low point compared to here. From front to back, looks like we are going up. So here, the back of the house is higher than the front, which means any water that falls at the back is going to tend to run towards the street anyway, which is good. It stops us from having to do sumps and pumps and things like that. Again, you'll learn all of that down the track. Once we've done, put our tank in, let's come through, let's put in some downpipes. So let's just work out where these are going to sit. Well, I know I need to have one somewhere here because this part of the roof will fall down. This part is a boundary gutter, which will also fall down. So I'm going to have to put one in here somewhere. I have this area of roof carrying a fair bit of water. So I might put, you know, one roughly there, then another one here at the corner. This roof, I'm going to need one here on the corner because this section will catch water, it will run down, fall this way to the downpipe and go, or it can fall either way. They can make a higher ridge in the gutter and have it fall both sides. This here is a very long span of roof. So as a general rule of thumb, you know, we can put these in at about 6 meter intervals or 9 meter intervals. What you'll find is we'll put them in and your trades will change it anyway. Downpipe somewhere here as well. So let's put one here in the corner to hide it. Escape. This roof here is quite complicated. There's a feature roof here, which is going to collect water somewhere. So we've got to also think about the architectural side of stuff and where we're going to put another downpipe. So we can put another one here, or even here. So on this corner. So what will happen is it will catch any water that sits on this side. The gutters will fall to this point. Here will fall to this corner. From there, go down the downpipe through the ground. Okay, so what I can now do is ungroup this, and I don't need my roof anymore. My roof has been there to guide me for the areas that's going to catch what water, but now I don't need it. And I'll show you why in a minute. So we're just going to move out the way for now to stop confusion, and we'll put it back after. So moving the entire roof again. Move, let's just sit it over here somewhere. Ortho on. Let's move it by 15,000. Now I can select that whole thing, group it by itself. So where are my downpipes sitting? Well, my downpipes are effectively going to sit on the inside of my walls. Why is that? Well, go have a look at your house. What you'll see is you'll see your eave line, the outside of the house. You have a gutter on it, and the downpipe will bend back and come down the wall of your house. They don't sit and just hover outside. They all bend back towards the walls. Which means my downpipes sit, you know, here somewhere. So what we're doing here is we're not designing things. We are. This has to go to council as a part of your civil plan. We're showing that we've considered the drainage. We know what's going on, but effectively the guys that are doing it, installing it, the plumbers and everyone else, they're not gonna even bother looking at this. I almost guarantee you. So now I need to tidy this up again. Well, I've got clash here, so let's move this out of the way. The reason why I can do that is because I can assume this level is in proximity to it as well. And same thing over here. Let's move them out of the way. These plans get very busy, as you know, you've all seen here. They get very complicated and very busy. So we need to just move things around and make them all look very neat. Sorry, I also need to take this here. I will give you all of these little things in the CAD file that I'll upload this week. The reason I'm scaling up by 2 is because these plans are scaled at 1 to 200. So the civil plan or the site drainage, as well as the site plan, are scaled at 1 to 200. So let's take this downpipe here. Let's take all of it for now. Copy from here. Take the ortho off. I'm going to place these around. Well, I have one sitting on this. Well done, Nathan. I have one that's going to sit over here. I'll just trim this line. This line here is representing the pipework. So let's just trim it for now, and we'll stretch them out after. Okay, where else are we putting one? Well, I've got one somewhere here. I've also got another one sitting here. I have another one here. Downpipe in front of my garage. Put one here by the porch to catch that water. And another one here. Let's go up this side. Well, got one in the middle. And I have another one sitting here. Now, what you're going to notice here is these plans aren't super accurate. We're not taking measurements, we're not doing any of that. So this here is more based on understanding than anything else. Rotate this around so the pipework is at least facing the way that I want it to go. And we can do the same for all the others. So that way, I'll tidy the ones up after. But what I need to do is I need to put in where these are going to sit. So let's come with a line. Let's move it down onto pipes. Start with a line. Let's change the color. And what I'm going to have is I'm going to have a line starting from here, ortho on. It's going to run up from the house. It's then going to run along the backyard to here. Then it's going to connect to my tank. Here, trim, enter. I'm aware this isn't lining up at the moment. The reason for that is it's not straight because the other house has been rotated to be on an angle. So to fix that, let's just draw one in. It's 2.5 by 750, sorry, 1.5 by 750, 1500, negative 750 by 1500. Yeah, that didn't work. Well done. Let's just come here then and draw one that's straight. I'll give you the exact one in the file, so don't stress. It's just for my OCD, as always, the fact that I don't like seeing things sit out like this. Nathan, what are you doing? Okay, we're getting there. Sorry guys. so it connects to the tank. Well, if that's connecting to the tank, all of these downpipes here have to as well. So I continue again with these lines. So this one might come down a little bit, come across to say here, or even further under here, under the driveway. And then because these are pipes, they don't have to run at angles like this, and usually they won't. So I can show it on an angle here, like that. No reason why I can't. Offset by 40. And I know what you're asking, why are we offsetting by 40? Well, these are scaled at 1 to 200. These pipes are usually, I think it's 90mm diameter pipes. We use 40 because when we scale it down, having these sitting at 20mm, so half the width, it shows really well on a PDF. So when we print them out, it's for the representation of it. They stand out really well if these lines are 20mm. Bigger than that, you start seeing two lines and it looks like there's more pipes there. So it's just from practice, and it is what it is. So match properties, let's take it from here. Well, matching these is showing my pipe work. And here. Cool, now I've got a bit of overlapping. Obviously these are continuous, so let's chamfer the ones that are clashing. There's okay. Well, here and here. That's okay for now. Let's chamfer these. To there, awesome. So let's trim in here. Cool. So what's happening is the downpipes are going to connect to the pipework underneath the ground. They're then going to go to the tank. So this tank here, the rainwater tank, will be used for irrigation. So they'll use it for the water in the backyard. They'll also use it for the toilets. So they'll connect this to the toilets, so you're not using mains water to flush. Next thing I might do is move this to the corner, or to the other corner. So let's just move it over here for now. I'm doing really well. Sorry guys. So let's move from here to here. Please don't snap to anything else. It's better. Let's move this downpipe notation across. Rotate to about here. Trim, well, let's trim these, that, and that. Extend to this line. Trim in between it to there. Oh, same thing here. Now this is kind of in the way. So let's move it to the other side to here. We can still use that as a reference spot level for this point, so don't stress. Well, let's keep going. Rotate this one around. Move it across a little bit. Extend to this line. And trim to here. So you keep going, you do them all. So same thing here. So here, well, these are sitting hard up on top of each other. So what I might do is I'll try to move it in a bit. No, that's not really helping me. So why don't I try to move this out? There's no reason why I can't. Just for the look of it, let's bring it out a little bit. So again, same thing. Now I've done that, I have to just tidy it up again. Should have moved that by a known value. Well done, Nathan. Cool. Delete that, delete that. Extend to here. What am I extending? Extending that. Extend these two, extend that. Come back through that entire process again with the trimming and the cutting, and we'll be there. We'll get there. So that one as well. Alright, now we're on a roll. These ones, that one. Through here, through there. Haven't extended these ones yet. Okay. So this one here, I can move a bit across to the corner. That one's okay. Well, let's rotate this a little bit to say there. This one here as well to there, and then move it away. And how's this one looking? Better. All right, what do I need to do? Well, let's extend these again. Alright, it's a bit messy, but we'll tidy it up. Trim here. Now it's looking really messy. Like I said, I'm doing really well. Sorry guys. So there. That looks a bit funny. I don't like that. Let's undo it. Delete them. Let's move these to here. And now let's chamfer this again. Alright, almost done with the roof, and then we've got more to go. Trim through here. Don't know why that chamfer thing's just come up, but that's okay. Cool. Alright, so that is our roof done. So it's all the water collected from the roof comes to the tank. And then what happens? Well, like I said, from the tank, when the tank fills up, we discharge to the straight line, gets me to here. So to about there somewhere. And then I don't have information here about the stormwater, like the outlet, but it's going to be somewhere about here. Offset again by 40. Here to here. Here to here. Chamfer. This one and that one. And they're okay. Match the properties for these two, for these two. So that's the stormwater coming to the outside. So it collects all the water from the roof, fills up to the tank. Once the tank fills up, well, it just discharges it to the straight water, and off it goes. Now that's just taking care of the building. Like I said, there's two spots for water to land. It can land on the roof or it can land on the ground. So for our runoff, which is what hits the ground, got a few things we're going to have to do. Well, I need to put in some little grates around here on both sides. So what I might do is all of the levels on this side, I might move them just to the other side of the boundary, to about there, showing that they're still there, just to clear up where my drawings are going to sit. I have to put some in the middle as well. So let's move these numbers in a bit. Okay, so that's cleared the path there. So grab my grate, and what I'm going to do is, because I have earth here or pavement, I can obviously have water landing here. So I'll just start here. I'll put another one somewhere here. I'll let it run for a bit. I'll do something different in the backyard for now. What we're going to do is we're going to use a graded sump. So what we'll do is we'll illustrate this by going 150, I think it's 150 by 150. That's very small, Nathan. It's not gonna work. Sorry guys, I'm just having a mental blank at the moment for the measurements here. 500 is what it is. 500 by 500. Draw a line through here and through here. So what this is basically we'll draw some arrows around it, and they'll scratch the ground to make it fall to this point. Be a grate on top of it, all the water will fall to it and then discharge from there. I will show you the photos of what these look like on Thursday when I see you. But for now, just trust me, this is what's going on. So to draw some arrows in, let's say 1,000. Let's come back by 250. Rotate at 45. Mirror about this axis. No. That's better. So what they'll do is they'll fall, so they'll scratch all the ground to fall to a low point. So any water that hits the backyard will fall to this point and then get carried through our pipes. I know it's probably not the best explanation of this, but I'll go through it again on Thursday with you. So what I'll do is let's move this spot level away a little bit within reason. So I'm not going to chuck it over here where it's not true, but within reason I'll move it around so it's still close enough to that point. And let's move this one down a little bit. Let's say to, yeah, about there. Alright, so what's going to happen with our pipes? Well, I'm going to have some pipes which are obviously going to start here. They will then run straight up. Let's find the midpoint of this. It's about there. They'll then run straight through to here. Now, I know I said these pipes can never meet. So what collects on the roof doesn't meet the groundwater runoff. So collect it on the ground, discharge it straight to the street, collect it on the roof, to the tank, to the street. What we can do is the water that discharges from the tank, we can discharge our groundwater runoff to that pipe. This pipe falls away, doesn't fill the tank, this pipe fills the tank. So they'll never meet, which is good. Offset again by 40. Again, just for the aesthetics of it. Let's come through, match properties from here to here to here. And now we've got to tidy this one up as well. But I can also have water falling on the pavement on this side. So I need to fill these bad boys over there. So copy from here. Well, let's just try to put one, say here. Let's move another one here. I might have a few on this side. Might have 3 or 4, I reckon. Let's put another one, say here. That should be okay. Our plumbers know what they're doing here. We need to show the council that we've taken into consideration. We know how things are going to drain, and then it's our trade's problem. We don't have to put anything in the front yard. If we look at the fall here, we're falling towards the street. So what we have is 98.84. The water table is down here. Top of the curb is lower as well. Here is higher than the front of the block. Here is higher than the front of the block. So the water that hits the front yard is just going to fall towards the street anyway. There's no point collecting it. We just let it go straight. This connection here we need to worry about. So these lines can't meet. One will go on top or under the other. So what do? Well, we come with a nice circle. We'll draw a circle here, say 150. And we literally jump the lines. So offset by 40. Let's go to the outside. Trim. Well, if I'm jumping the lines, these here don't matter, but the other ones do. So I need to work out a way to make it look like it's jumping. So let's trim these up. Trim, let's also trim this up in here, to there, to there. So what it looks like is the water gets collected, so all the water collects in here, will run to this pipe, it's falling down this way, and then we'll go over or under this line and straight to the discharge. So we just have to come through and tidy it up. So let's tidy these in here. Chamfer on this corner here. Let's trim in here. If you start getting it here looking like this, if you don't like the look of it, what you can do is you can draw a circle somewhere, trim inside of the circle, and that's made it worse. Well done. Should have made a bigger circle, Nathan. Trim to that one. And that hasn't really done too much. Why is that? Well, these lines aren't the same. That's why. Because they're not the same length, that's not going to work. So what I might have to do is effectively do one at a time. So these here are lining up. Now these are separate lines, so let's do another one over here. So all I'm doing is drawing two little reference points to cut from. Let's see if that looks any better. Well, it's better up here. It's not so much better. Well, down here it's not too bad. It's really just this middle part. Okay, so I can do a third one to tidy it up, but that's okay. But sometimes that can be really bad. You can have real kind of awkward differences, or you can just change the scale of the lines. So let's come through again. Move this so it sits on top of the pipe. Trim to this line here. Well, let's cut this one and that one. And I've done the same thing here. So you can come through and tidy it up after. Trim here. What are we trimming? Let's trim these two. Trim again. Let's trim these two. And I still get, this is what I'm talking about, this here annoys me. That's much better. Look how much more aesthetic that is. Okay. Oh, that's okay. So that's it. That's our site drainage done. We've got annotations and levels and stuff we have to do. Well, let's go ahead and do the levels now while we're here. What I have is just a quick recap. I have the water hitting the roof, runs down our downpipes, which is this line here, runs down our downpipes, runs to the tank. After it hits the tank, it discharges the entire way, runs down and comes out at the street. The water that hits the ground, the surface runoff, comes into our little grates, runs in. Any water that's falling in the backyard here falls into this sump, then comes through, comes over our inlet line and comes out to our discharge line. Okay, so now I can put this roof back across. Here's my ortho on. Move it straight back by, I think it was 15,000. So my roof is there. Cool. So once I've done that, the next things I need to do is, well, this roof here is kind of in a bad spot where these dotted lines are sitting because they can be seen to be pipe work. So I have two options that I've got. I can either remove the roof entirely, like the whole roof off the drawing, or I can trim these lines. I haven't decided what I'm going to do yet, so I will leave that for now. Okay, what's next? Well, I have another house I have to put here. So you can repeat the entire process again with a house here. It's the same house, same floor plan, is going to sit on this side. So I'll let you guys go through and redo all of that on this side here. I know what you're thinking is, Nathan, that was a lot of work. I don't really want to do that again. So what I would recommend is effectively you select everything we've just drawn. You can either come through, lock and unlock layers or whatever you want to do, or select them one by one. Entirely your choice. And what I would be doing if I was you is select it all and just copy it across. So what do I mean by that? Well, the houses are the same on both sides. Exact same house, has the exact same stormwater connection. It's the same roof, same everything. So if I select it all, what I already have, in theory, I should just be able to copy it across. Making sure I grab everything. these ones here that are touching this boundary, I have to move back. They can't sit on the other side of that boundary there. So once I've done them, I would copy. Where am I copying from? Well, this point here, in theory, is the exact same as this point here. How does that look? Cool. So there's 2 houses done for the site drainage. That's sitting on that line. That's not in the corner, Nathan. It's okay. I'll just pretend that's not there for now. Making sure it's not cutting the boundary, so it's still within inside. That's okay. And there we are. So you can tidy this up, but we've got 2 of our stormwater or our site drainage plans done. What we need to do is we need to come up with our levels. So what I'll do is I'll pause the recording here and move on to another one. I'll go through how we come up with our levels and then how we put them on the sheets. Alright, so please make sure you do this, and I'll see you guys in the next one.